Hello, everybody.
How's it going?
I'm good. Thank you. How are you, Laura?
Good, doing well, thanks.
Glad to hear it. Yes, we are live. How exciting. Yeah. If you're watching live, thank you so much for joining in. This is our inaugural live stream at Suborbital. I'm so excited to do this. And well, since we're starting, Laura, would you like to introduce yourself?
Yeah, I'm Laura Langdon. I have just joined Suborbital 3 weeks ago. And I'm a technical writer here at Suborbital. I used to be a math lecturer.
Wonderful. Wonderful. Yeah. Thank you so much for joining in and for doing this with me today. Yes. Hi, I'm Ramon. I'm here on my 4th week at Suborbital. So I'm here just a touch longer. And I'm a developer relations engineer. And yeah, all about open source stuff. I'm coming to you live from Vienna in Austria. Laura, where are you tuning in from, if I may ask?
The San Francisco Bay Area in California.
Yeah. So we're like 9 hours apart. So this is extraordinary to be able to do. Yeah. Excellent. Well, let's talk a little bit about what we're going to be doing today. Today, we're going to be kicking off a series of streams all about getting into WebAssembly and doing a little bit of learning about WebAssembly. This first week is going to be just like us hacking on, I say just, it's really not just. We're going to be hacking on our very own WebAssembly app, following a tutorial. Going to be super fun and easy. We'll get as far as we can, and then we'll be happy to, folks in the chat, feel free to chime in. This is us pairing, but not so much pairing. This is also an ensemble situation we've got here. So if you're joining in live and you want to chime in with some ideas, suggestions, documentation, if you see us get stuck and you have an idea of how you can help out, please join in. This is what we're doing this live for. And yeah, I think it's fair to say I've done very, very little WebAssembly myself. How about you, Laura, if I may ask?
I would say it's basically zero.
Yeah. So we're going to be like, if you're watching and you've never done WebAssembly, trust me, you're in good company. Laura and I are super fun to learn with, and we're just going to like figure it out together.
Yep.
So I'm going to go ahead and share Laura's screen. So Laura's going to be driving today. If you're familiar with pair programming, Laura's going to be driving. That is, she will be doing the coding, and I will be navigating. That is sort of navigating. So, sort of taking us in the direction that we need to go in. And yeah, let's go ahead and share Laura's screen. So here we go. What do we have here? Could you tell us a little bit of what you've set up here? Before you do that, folks in the chat, we've made the text a little bit bigger, but if you need us to make it even larger, please let us know. We'll happily zoom in as needed.
Yep, so here we have a tutorial on Rust and WebAssembly, and this is the tutorial that we're going to be using today. And then we also have Visual Studio Code, also known as VS Code, and a terminal window all ready to go. And this tutorial is going to walk us through setting up a WebAssembly app that will build Conway's Game of Life. Ramon, do you want to tell everybody about Conway's Game of Life?
Sure thing. Conway's Game of Life is a sort of, I believe it's a Turing complete, I could be misusing that term, programming environment, often used as an exercise for learning programming languages, where you have these cells in a 2x2 matrix, like a rows and columns of cells. I'm about to butcher this description. And these cells can either be alive or not alive, right? And depending on their environment, each time we tick, so there's sort of a ongoing clock in Conway's Game of Life, and each tick, depending on the environment of a cell, those cells will change from alive to not alive, or vice versa, or even stay alive or not alive. How's that sound?
Sounds good.
Yeah, fantastic. I'm going to go ahead and paste the tutorial that we're going to be using into the chat here. So you should see it. I hope folks, please, as I said, always chime in if you've got any questions, something like that. We're still figuring out this whole streaming stuff out, so please bear with us. And yeah, so we're going to be using we're going to be using WebAssembly to do this, but we're going to be programming in a different programming language. What's that, Laura?
That's going to be Rust, which I have also never used.
Fantastic. Yeah, we're going to be doing like a lot of things for the first time today. It's going to be super chill. If you're not familiar with it, Rust is a programming language that's relatively new in the grand scheme of things. I think it's not 40 years old like C or something. I think C is older than that. In my head, it's still 2000. But yeah, right. Rust is a relatively no systems, like often used for systems level programming language that prioritizes memory and thread and type safety. I could be butchering that again, but that's my understanding of it.
Mm-hmm.
And yeah, we're going to be using WebAssembly to do that. And do we want to cover a little bit what WebAssembly is?
Sure.
Awesome. Yeah. So we've got this book which tells us everything we need to know, which is fantastic.
Yep. Although, yeah, this is not super telling us what WebAssembly is. Do you want to go ahead, Ramon?
Sure. Let's first read this out. So let's see. WebAssembly, or which is sometimes abbreviated as Wasm. So if you hear me say Wasm, we're referring to WebAssembly. Is a simple machine model and executable format with an extensive specification. It is designed to be portable, compact, and execute at or near native speeds. As a programming language, WebAssembly is comprised of two formats that represent the same structures, albeit in different ways. We've got the WAT text format, called WAT or WebAssembly text, and we got Wasm binary format, which is a lower level and intended for consumption directly by Wasm virtual machines. Yeah, you're right. It's not super extensive, like because what we want to. Jagger says the 90s were 10 years ago, right?
Where
And
we actually have some better explanation on our website, even.
Oh, fantastic.
So let's have a look here. Here we are.
Awesome. Could you do me a favor, please, and zoom that in? Maybe one more, please. Perfect.
In particular.
Yeah. Love this. Let's read it out. Oh, do you want to read it out?
Sure. So WebAssembly has really three main advantages: performance, portability, and security. So WebAssembly is portable, meaning it could be run on any operating system or hardware architecture. WebAssembly is performant, providing nearly the same level of performance as native code. And WebAssembly is secure, ensuring code is executed within a sandbox that embodies deny by default security.
That's interesting. So what that last one I kind of stood out to me as in deny by default. So usually a lot of programming environments would have a deny by choice security. Is that correct to assume?
Oh, I'm just going to go with yes. Yeah.
I think I'm very likely wrong about that, but yeah, a lot of the times, a lot of times we usually have essentially all doors open to us. And what WebAssembly does, for example, is have all those doors closed. If we're thinking in a metaphor, right? Doors as an access to things like native libraries, system level stuff, operating system commands, and that sort of thing. I could be completely butchering this once again. But yeah, so what WebAssembly does is, on the contrary, say like, hey, everything is denied by default, and you need to explicitly request permission within your WebAssembly module or app in order to enable that. Now, a little bit of the history of WebAssembly, from my understanding, is that it started out as a way to write performant apps written in other programming languages in the browser. And that other programming languages is kind of key here, because usually the number one the default programming language meant for browsers is JavaScript.
Right.
So all browsers will come with a JavaScript engine that can interpret. That's it. Interpret JavaScript. So WebAssembly would then become a target, a compile target. So if you're familiar with this concept, usually programming languages that are not interpreted like JavaScript usually are compiled. Right?
Right.
So things like Rust, for example. Rust is usually compiled to native language or machine code. And this comes in different targets, things like, depending on the architecture of your computer, this can be things like PowerPC, Intel, like 32-bit, 64-bit. The newer MacBooks now have M1 targeting, which I believe is ARM.
Right.
So if I'm just spouting out mumbo jumbo, these are jargon. Sorry, not mumbo jumbo. Different jargons. These are just compile targets for these programming languages, and WebAssembly is a relatively new target for that.
Right.
I hope that sounds good.
Yeah, sounds good to me.
Awesome. So going back to what we're going to be doing today, we're going to be writing our own WebAssembly module in Rust. And we're going to be doing that using Conway's Game of Life. And so a little bit of what we're going to be doing today, we're going to be setting up a Rust toolchain. And I believe we're going to need to set up Rust as well. So we're going to start like super from zero here. Is that correct?
Absolutely.
Awesome. And we're going to be having a little web app that runs that WebAssembly module.
Mm-hmm.
So yeah, let's see. So we're going to be learning how to set up Rust toolchain, a workflow for developing polyglot programs made from Rust, WebAssembly, HTML, JavaScript, and CSS, how to design APIs to take maximum advantage of both Rust and WebAssembly strengths and also JavaScript strengths, how to debug WebAssembly modules compiled in Rust, how to time profile Rust and WebAssembly programs, and how to make those WebAssembly programs smaller and faster to download over the network. Yeah. So let's start with our installation step, please.
Right.
Oh, and I should add, all of this material, like what we're reading here, this is open source. So what I've posted here, if you find anything you'd like to expound on or contribute, please feel free to contribute to that as well. Yeah. Cool. So we're going to start by we're going to set up our computer in order to be able to run our WebAssembly app. And we thought it'd be fun to do that from scratch.
Mm-hmm.
So the first thing we're going to be setting up is the Rust toolchain. And that's going to take us straight to Rust's website, and very friendly so. It's going to have a little command there that we can paste into our terminal. I always want to say, be very careful when pasting stuff into your terminal, but this is the Rust website. Like there should be a modicum of safety there at least.
Mm-hmm.
So we've pasted that command into our terminal. We're going to proceed with a default installation, which Laura did there by pressing number 1. And now it's just going to set up Rust. Do we want to cover briefly like what's going on here?
Could you?
Yeah. We're essentially downloading the Rust programming language environment. So this is setting up our computer in order to understand, it's installing some programs and commands into our computer so that we can run Rust.
Right.
So Rust is installed now. Great. I can see that in the terminal. Again, folks, if you're watching and you'd like the text size to be a little bit bigger, please let us know. So this should get you started. You may need to restart your current shell. This would reload your path environment to include cargo's bin directory. To configure your current shell, which again, a shell is like our current instance of the terminal. Let's run source home cargo env. So let's go ahead and do that. Awesome. So we're gonna do, and what
Where am I looking at?
Oh, I think you're missing a $sign before home.
I can't see on the. Is it on my screen? Because I don't see it.
It is on your screen. Oh, I wonder why it's not showing up for you.
Is it? Oh, hang on. I'm looking at the wrong. Gotcha. Wait, where are we? I think
I'll find it.
Oh, yeah. I'm just looking at the wrong place.
Ah.
That will be better.
You'll need to delete all of those. Sorry. So now you can go ahead and paste. Oh. All fine. Nice. So we're gonna go ahead and copy paste that. We're programmers. We're lazy. Awesome. So that's now done, and we can actually go ahead and test that Rust is installed. And in order to do that, I usually just go with Rust. There's a program called Rust C, which I believe is short for Rust compiler.
Okay.
And then let's add a space and a V flag, and that's gonna check the version. Nope, it is not. But hey, we got an error. No input file name given. That tells me that we did it right. That at least Rust C is installed, which is a good thing.
Yep, it's installed and it's mad at us already, so we're off to a good start.
We're off to a good yeah, exactly. So the next thing we're going to go ahead and install is Wasm, which is our one-stop shop for building, testing, and publishing Rust-generated WebAssembly. So what these are essentially command line tools that make it really easy and straightforward for us, and thankfully from the open source community, for getting up and running with building WebAssembly apps with Rust right from the get-go. And I just love this mascot here, Ferris. They're so cute. And I love the little builder hat with WebAssembly logo on it. Cool. So that was actually done super fast.
Mm-hmm.
So successfully installed Wasm 2, and that's our path. We can actually also test that that's installed.
Okay.
And I think we can do that with Wasm-pack. And then let's try the V flag and see if... Okay, so the V flag... Oh, it's capital V. Sorry. But hey, we can see there that works.
Interesting.
Yeah.
These things should be standardized. I'm sorry.
No, you are absolutely right. Like sometimes it's -V, sometimes it's dash version, sometimes it's dash version. Having options is good, but also a bit of a double-edged sword. Cool. So we're going to be installing our next thing, which is Cargo Generate, which helps us get up and running quickly with a new Rust project by leveraging an existing Git repository as a template. Cool. And Cargo, if you're not familiar with it, is kind of, I would define it as the NPM equivalent to Rust. There are probably people watching who are saying, "Oh, Ramon, there's so much more to it than that," and you are very likely right. But we're learning, so please feel free to correct me in the chat. That's what I'm here for.
In any case, it is a package manager.
Thank you. Yes, absolutely. Yes. So what it's doing here is downloading the very big bunch of dependencies that that Cargo Generate depends on. So while it's doing that, let's take a look at what else we need to install. If we could scroll down a little bit, please. So the next thing will be to set up NPM, which we were just talking about. And NPM is short for Node Package Manager, and is I'm gonna be very cheeky here, the Cargo equivalent for JavaScript. It's a package manager for Node modules. Yeah.
Mm-hmm.
So once this is done downloading, we're gonna if we haven't already, and I believe NPM is installed on your machine, is that right?
It is.
Yeah, because we're doing some Node stuff. So if not, there's some instructions here that are linked very nicely for setting up NPM. But yeah, we can go ahead, and once that's done, we can just what we're going to be doing in this command is installing NPM, the latest version at a global level. That's what the G flag is for. Mm-hmm. So that's telling us like, hey, please make sure that NPM is at the latest version. And I can see there in the terminal that it's building. So what that's doing is essentially compiling the Rust so that it's runnable on our Mac. Is this the Mac, right? Yes, Mac OS. Nice. Yeah, and Rust should be... Oh, I'm going to read some of the chat if I may. Seichan writes, "Love the learning vibes here." And thank you. Yeah, we're here to learn. We're like, this is us like getting into Rust and WebAssembly for like a proper... I think I've only done this tutorial once, and I've done a little bit other than that, just like doing like hello world stuff in WebAssembly. So we're here to learn.
Yep. Learning in public.
Learning in public. Yeah. Awesome. Oh, this is...
Love that 160 out of 161.
It's not a round number, which is frustrating.
No, I just mean like it's always, we've done everything but one thing, and that one thing is going to take, forever.
Yeah. It needs a minute. But that's totally... Oh, do we have an error? Oh, okay. Could not compile Cargo Generate due to previous error. Shall we go ahead and scroll up and let's just see what that error is? Linking with C failed, X's status 1. I have no idea what this is. Do we want to try and like plop this error into our search engine and see what we get? And Yeah. Yeah, let's go with that first Stack Overflow result. And if you don't mind, please, making it just a touch bigger. Oh, I think it's a Mac thing because I see. Could you scroll down a bit, please? Thank you. So, I was faced with 3 problems on Mac compiling Rust. If you have any issue with writing files or with ILD, just remove that files and try to recompile. Don't know why, but on Mac this issue happens from time to time. Try to add the following sections to your cargo config. If you don't have this file, feel free to create. Okay. Third, sometimes your Mac lacks some of the dev tools and dependencies. Install the most important of them automatically with the command xcode select install. That xcode select stuff is sounding familiar to me. This is the this is specific to Mac OS, and I believe it's the, what are they called? Oh no, command line tools are already installed, so that's not it.
Last night, actually.
Oh, you did it last. Okay, fair. And this is why I love doing this live. And folks, if you're watching and you're probably like, they're not going to get to the end of this, are they? We might not. And that's totally fine. We can come back and do this. We can, have a follow-up stream.
We should totally do that.
Absolutely. Cool. How about we try the second one?
Okay. So would we create that file in this directory, or do we need to go out into the root directory? I would guess.
I believe we're in the home folder at the moment because I see there the tilde. So maybe it already exists, this cargo config file.
Maybe. Where
Let's
would I
give it a
look?
try? I might recommend opening it up with VS Code. Do you have the code command installed? So that's CMDE,
no.
and then paste in there. That one, yeah.
I don't think I do have the code command installed in here.
That's fine. Let's go ahead and do it with Vim then. Vim is a terminal-based text editor. If you're not familiar with it. And yeah, let's go ahead and plop that in there. If this doesn't work, we might want to remove that file. Perfect. So we're gonna, I think there's a trailing tilt. Is that possible?
Trailing?
Like in the last line?
This one?
Yeah. Is that like a...
That's really interesting.
Could it be you need to delete that? And then put in the closing square bracket. Perfect. That looks good. Nice. So we've reconfigured our Rust, hopefully to work. Shall we try doing the cargo install again?
Hopefully it won't take 7 years to tell us that it doesn't work again.
I fear it might, because I fear it might because I believe we're telling it to compile these files differently now. So it might actually take a bit. But that's fine. That's fine. We've got time. How about we go back to our tutorial and see, just sort of explore in the meantime what we're going to be doing next.
So we've already talked about doing npm next. So this will be the next.
Yeah. And then what we're going to do is essentially set up a hello world, making sure, as the instructions say, to follow the setup instructions before beginning, which we hopefully have if everything works. So we're going to clone the project template. And this is where that cargo generate comes in handy, because instead of making a fresh cargo package that is essentially making a fresh Rust project, we're going to generate it from a template, which the folks at Rust Wasm have very kindly provided for us. So if you look in the command, like clone the project template with this command, there's a Git URL, a GitHub URL there. And what we can do is actually go ahead and plug that into our browser and just have a poke around. Could you please make it a bit bigger?
Yes, of course.
All good. Awesome. So there it says in the about part, a template for starting a Rust Wasm project. And there we can see how to use it. Use cargo generate to clone this template. We can build it with Webpack, and we can test it. It comes with tests, so that's pretty exciting. Are you familiar with tests in code?
I am familiar with the concept.
Yeah.
I have not actually written almost any.
Well, I mean, if the tutorial gets her there, I hope we can give it a try.
Woohoo!
Trying lots of stuff for the first time.
Mm-hmm.
Wonderful. So here we are at our 161. I'm feeling pretty good about it.
Good. Why?
I'm an optimist.
That I can get behind.
Woohoo! Yep. Hey, would you look at that? We did it!
Yay!
This is one of the things I love that I love about getting into coding in general, is that a lot of folks kind of fear that relying on Stack Overflow is probably not a good sign. I very what's the word? I very respectfully disagree, because I feel like, sometimes that can lead us in the right direction, especially when it comes to like, I remember this. We had this last night.
That's right.
When trying this out.
Yeah.
We don't have permission, so we're going to do a sudo npm install. And I want to read a comment by Seichan, if I may. It's so reassuring to watch you two, because sometimes I feel like the only one to make a mess while trying to follow tutorial steps. Nope, as you can see, happens to all of us.
And that's exactly why we wanted to go through this, because this is something we talked about yesterday. Like, should we show the setup process? And we were both like, yeah, let's show all the mess.
Absolutely. So yeah, thank you for contributing that. Cool. So we're going to be cloning that. We're going to be creating our project with cargo generate. So we're just going to paste in that command, and we're saying like, okay, it doesn't have a config file, and this should prompt you for a new project's name. We will use Wasm Game of Life. So we'll just go ahead and paste that in. Perfect. So we can see here, it's generated a bunch of files, including a git ignore. So it's going to be pre-configured for git stuff. Cargo toml. I see some Rust, some src librs, Utils Rust. I don't know why I'm pointing. Nobody can see that. And some tests. So that, and we've got a new project inside the folder, Wasm Game of Life. So we can go ahead and cd into that.
Okay.
Perfect. And you use tab to autocomplete that, right?
Good.
Nice. Cool. Excellent. And there's those files that were generated. And if we go back to the tutorial, we can see essentially what took place there. And this tutorial is really nice because it walks us through what each of these files are. For example, the cargo toml. Shall we open up this project now that we have it set up? Shall we open it up in VS Code?
Mm-hmm.
Excellent. Perfect. Yep, we trust the authors because we're the authors. Excellent. Let's open up that cargo toml file real quick. Perfect. So you'll have to forgive us, folks. We don't have a ton of screen real estate. So we'll try our best to make that work. If the size is too small, again, always please feel free to let us know and we'll happily make it larger. Thank you. Perfect. That gives us some space to work with. Yeah, so we can see here the name of the project. So I'm just going to read out from the top. We've got a package definition with the name, Wasm Game of Life. We've got a version. That's a version for our app. We've got authors, which is you, and that comes from your Git configuration. So the cargo's clever enough to automatically infer that, which is pretty cool. The Rust edition is 2018, I think. And we've got dependencies, which is Wasm bind gen, which, let's see here, this one comes pre-configured with a Wasm bind gen dependency. That is a pre-existing cargo library, or as they're called, crate for bind. I'm guessing for generating bindings to Wasm, between Wasm and Rust. This is something I'm guessing based on the name. That is, creating those links between Rust and Wasm. A few optional dependencies we will dig into later, and the crate type properly initialized for generating Wasm libraries. And then we've got the src librs file.
Just going to
nice.
configure. There we go.
Oh, nice. Yeah, this works. Thank you. Yeah, so we've got the src folder. Let's go ahead and open that up in our VS Code and take a look at librs. And this is code that was generated for us. You know what, Laura, could you actually make it one touch bigger, please? Perfect. Thank you. Cool. So we've got here some pre-generated Rust code that's essentially leveraging Wasm bindgen to create a sort of hello world sample Wasm app. So and if we see here in the tutorial, it uses Wasm bindgen to interface with JavaScript. It imports the window.alert JavaScript function and exports the greet Rust function, which alerts a greeting message. So if we see on line 13, it's leveraging that window.alert functionality from JavaScript. If you're not familiar with it, JavaScript with the alert command with window.alert will just show a pop-up saying whichever text you supply to it. So it takes as an argument a string, or as it's called in Rust, a string slice. And there is a differentiation between the two. I couldn't tell you off the top of my head what they are, but I think it has to do with accessing where in the memory of the computer Rust fetches that data from for the string. And sorry, did you? By the way, Laura and folks in the chat, if you ever have any questions on my rambling, please feel free to interrupt me.
Will do.
Yeah, fantastic. Thank you. Cool. And in line 17, we're defining a public function called greet, which is bound to Wasm, where we call alert with the string slice parameter hello, Wasm game of life. So our objective is to export this to JavaScript, this Rust code to JavaScript, so that we can alert with hello, Wasm game of life. Sound good?
Yeah, let's do it.
Awesome. Next, we've got the Utils Rust file, which, let's see, provides common utilities to make working with Rust compiled to WebAssembly easier. We will take a look at some of these utilities in more detail later in the tutorial, such as when we look at debugging our Wasm code, but we can ignore this file for now. Always happy to ignore stuff. We've got a favor asked from Seichan. If we could zoom in on the code again, please.
Yes.
Thank you very much for asking. Hope that's better. If it's still not good enough, please let us know. Cool. So we will use the command line tool Wasmpack to orchestrate the following build steps. Ensure that we have a recent version of Rust installed, compile our Rust sources to WebAssembly with a Wasm binary via cargo, use Wasm bindgen to generate the JavaScript API for using our Rust-generated WebAssembly, and we will do that with the command wasm-pack build. So that's what Laura just put into the terminal. And now it's compiling our our Rust code into WebAssembly. And there's a warning there, function is never used. Seichan says, perfect, thank you very much. So we've got a function there that says function is never used, set panic hook. I feel pretty good about disregarding that for now.
Okay.
Since a warning doesn't mean a failure. It's just like, hey, this might be a problem later. Which is nice. This is what I like about compiled languages, is that they're pretty upfront about saying like, hey, just FYI, this could be a problem later.
Yeah.
Cool. So your Wasm package is ready to publish at Wasm game of life /package. And if we look back in VS Code, we'll see that a PKG folder was generated at the top. And what this is, and correct me if I'm wrong, is essentially a JavaScript package or an NPM module of our generated WebAssembly. And so let's go poking around, see what we got here. We've got a README file, which is interesting. And I would assume that this comes from being a Wasm pack template. So this is the README that's going to be generated if we ever publish this WebAssembly to NPM, which is a public listing of JavaScript modules. Cool. Awesome. And nice. It's in Markdown, so we can check it out, the HTML version. Let's see what else we got. Let's open up some of these JavaScript. So this is Wasm Game of Life bg.js. Could we scroll a little bit down on the tutorial? Because I think it goes through what these are.
Perfect.
Yeah. So we've got the Wasm Game of Life bg.wasm, and this is the WebAssembly binary that is generated by the Rust compiler from our Rust sources. Do we want to take a look at that one first? That's the purple Wasm file. Nice. And here it says, the file is not displayed at the editor because it is either binary or uses an unsupported text encoding. Do we want to open it anyway? I kind of want to.
All right.
And let's use our built-in text editor. And
it was correct.
Yeah. This looks wrong and kind of gnarly, but I believe that this means it was generated correctly. It's essentially binary data. So not meant to be read by lower level computer stuff. Then we've got the bottom JavaScript file, this one here, which essentially exposes our WebAssembly functionality to any JavaScript that wants to use it. And then there's some TypeScript files. So let's take a look at I don't know which one it is. One is .d.ts. I think they both are. Cool. So what this is doing is adding a binding for TypeScript. And if you're not familiar with TypeScript, TypeScript is a superscript of JavaScript that adds onto it, amongst other things, type checking, type safety, am I missing something? Generics. Yeah. And opinions in a good way. So what this is saying is like, hey, if you ever want to use this in TypeScript, know that the function greet returns void, which is TypeScript and other programming languages for it doesn't return anything. And then we've got the package JSON, which exposes that JavaScript functionality. It exposes these files. No side effects on line 15. Don't know what that means, but it's good to know that there's no side effects. And yeah, so what we've done with Wasm Pack is generated this JavaScript module. So now our next step is going to be putting it into a web page. So what we're going to be doing is, from inside the Wasm Game of Life directory, we're going to generate a fresh npm module. And with Wasm app and www. And what does that do? I wonder. So it's going to install create Wasm app. Sorry, it's going to install create Wasm app, and that was already done. Look at that little output there. Rust, crab Rust plus, is that a spider web?
Oh, you know what? I hadn't even noticed it, but yes.
Yeah, equals heart. That's very cute. I love it when terminal applications do that.
Yeah.
Cool. And that should show up. So I can actually see it already in our VS Code. That has for us a www directory. So and this is the npm package that was generated. And we can take a look at these files. A lot of this is going to look pretty familiar. It generates some HTML, some JavaScript. Let's just briefly, please, thank you. So we've got, this page contains WebAssembly. It's got a title of Hello Wasm Pack. What does index.js do? Let's take a look. Could you open? Yeah. Import from Hello Wasm Pack, wasm.greet. So it's essentially pre-configured to use that Wasm greet functionality. It imports the hello Wasampack npm package, which contains the default Wasampack's language compiled WebAssembly and JavaScript glue that calls hello Wasampack's greet function, which is good, but it's not using our Wasampack. Our generated WebAssembly. So what we're going to be doing is configuring our fresh npm app to use our generated WebAssembly. I believe. Yes,
Okay.
yes, we are. So first, we'll ensure that the local development server and its dependencies are installed by running npm install within the there we are. Within the Wasm Game of Life www directory. So back in our terminal, we're gonna need to cd into www. And from here, remember, we got our fresh package JSON set up. So we're going to run npm install, and the dependencies that are set up there are going to be installed so that we can run them already. This command only needs to be run once and will install the Webpack JavaScript bundler and its development server. Note that Webpack is not required for working with Rust and WebAssembly. It's just the bundler and development server we've chosen for convenience here. Parcel and Rollup should also support importing WebAssembly and as ECMAScript modules. But you can also use Rust and WebAssembly without a bundler if you prefer. Okay, so we're going to be using Webpack to provide to our web app the compiled JavaScript and WebAssembly. So the next thing we'll need,
First, we're going to have to fix some errors that our audit found.
So let's have a look here. So the packages were installed successfully, but here it's saying, hey, some of these packages that you installed are vulnerable. That means that they've been flagged by the maintainers as old version that should be updated. Now, usually I would say, let's do that. However, for the sake of the time of this stream, let's skip this step for now. I would suggest, if
Sure.
What do you think?
Yeah, I'm not worried.
Yeah, cool. Usually I would say it's the best practice to make sure that these are up to date, but this also ensures that we've got the versions of those npm packages that were meant to be used in the tutorial. So the next thing we're going to do is integrate our Wasm Game of Life as a dependency of our www web app. So we're going to open up in our web app, we're going to go to and open up package.json. Yeah. Perfect. And here, one of the things that we can list is a dependency. I don't know why it's scrolling. That's odd.
I think it's jumping around because it doesn't like being 1/3 size, but
that could be.
It can just deal with it.
Let's see if we can find the dependencies key here. So we've got dev dependencies, but we don't have dependencies, if I'm not correct, if I'm not mistaken.
Right.
So we'll want to maybe add a comma in line 35. And then below that, in quotes, start defining our dependencies key.
All right. Oops. Forgot the quotes.
All good. Oh, I think we copied that in there. Let's go ahead and delete lines 36 and 37. And yeah, line 43 as well. And since we already have dev dependencies defined in line 29, let's delete lines 40 through 42. And to write correct JSON, let's remove that comma in line 39 and the comment in line 37. Because I believe,
oops,
all good. I believe JSON doesn't allow comments. I could be wrong. Perfect. Okay, so what we've done here is we've listed Wasm Game of Life as our dependent, that compiled WebAssembly as our dependency in our www app. And the app, for clarity, the app is called www.
Okay.
So let's next do npm install again in the www folder. Yeah, we're still inside the www folder. Cool. So now it's listed that Wasm Game of Life dependency as part of our project. But the next thing we need to do is actually use it in our www app. So let's open up index.js and scroll up a touch there. Perfect. Now, could you scroll up a bit in the tutorial, please?
Oh, did I miss it?
All good. So we're currently importing star as Wasm from Hello Wasm Pack, but we instead want to be import star as Wasm from Wasm Game of Life. That's our npm package that we created. And Michelle says that with a hashtag character, you can do a comment in JSON. I did not know that. Thank you. Wasm Game of Life, and we're running wasm.greet. So essentially, when we run our app, I believe and I hope that it will import that Wasm package and then call that Wasm. Remember, that's compiled Rust code, wasm.greet.
Did we do that last npm install one step too soon?
We did.
Okay.
My bad. So next we're going to run npm. Oh, we don't have to do it again, but that's totally fine.
Correct.
And oh no, please don't apologize. And then we're going to be running a command called npm Run Start. Now, what this will do is run a script in our npm package called start. So that's doing a whole bunch of stuff. It compiled some Webpack. And in case you're curious, by the way, if you go to package.json in the JavaScript, yeah, that one there. If you scroll up, there is a key of scripts. So if you scroll up there, yeah. Scripts. And there we can see what start does. It startups a Webpack dev server, which is a Webpack dependency that essentially serves our web app as a local server. So if you have experience with web apps, this is making it available through localhost.
Gotcha.
And that's already running. So what the tutorial says next is navigate your browser to localhost at port 8080.
Yay.
Look at that. It's kind of small because I don't think we can zoom in here, and I apologize. But there it says, hello, Wasm Game of Life.
Yay.
So for the sake of experimentation, if I may suggest, what if we want to try and change that? That greet comment. Yeah.
Okay.
Shall we try and do that?
Sure.
Cool. Then where will we start?
So let's see. So one candidate is here. So just sort of following it backwards, right? So what generated that, the last thing that happened, I think, was this JavaScript command, the greet. Well, it's Wasm. Is this so at this point, is this is a JavaScript command, right? Because we're in a JavaScript file, but it's pulling it from a WebAssembly command
binary. I believe so.
Right, that we previously defined. So not in www, but in package.
In package, we that's where our compiled Rust went to.
Okay. So would it be the source?
Exactly.
Okay.
And that would be in lib. Yeah.
Okay.
And there we can see on line 18, we define the alert. Hello, Wasm Game of Life. So how about we change this just to see how the life cycle works? How about we change that to be hello? Let's do something fun here. Rustaceans. Have you heard that term?
No, but I'm guessing that it's related to the wee crab. How do you spell rustaceans?
So that's instead of it's crustaceans without the C at the beginning.
Yeah, I don't know how to spell that.
Oh, sorry. A and then CEAN.
Okay, so it's like
Perfect.
oceans, but with an A.
Yes.
Yeah. Okay, which makes sense because that's where they live. So that's okay. Cool.
So let's save that
Mm-hmm.
and let's refresh our web server. So that still says hello Wasm game of life.
Mm-hmm.
And the reason for that is because even though we changed our Rust, we still need to recompile it.
Mm-hmm.
Shall we try and do that?
Absolutely.
So the first thing we'll want to do is stop our Webpack server, which is usually done with Command C, Control C.
Right.
And then we'll need to navigate one folder out because we're currently in the www folder. And we'll run, I think it was Wasm build. Oh, by the way, I don't know if you know this. Laura. Have you ever used the Control R?
No.
Do you want to try it out?
Sure.
It's super fun. Please delete everything that you've got there.
Huh?
Now try pressing Control R on your keyboard. Now it's going to backwards search through your terminal history as you type. So if you type in Wasm, yep, keep going.
Uh-huh.
So Wasm-pack. There it is.
Aha. Nice. Thank you.
Yeah, sure. It's one of my favorite commands. So that's now compiled the WebAssembly, which is good.
Great.
So now we can go back into the www folder and rerun our server, I hope.
And what was that command?
That was Npm Run Start.
Okay.
Cool. That's compiled. Let's refresh again.
Yay.
And now it says, hello, Rustations. Cool. So now we know how to recompile our app from, like, if we want to make some changes to our WebAssembly, we know we need to recompile it and then reserve it.
Mm-hmm.
Cool. Good to know. When I usually read snips like this, like I was doing a JavaScript bootcamp for a while, I'd usually end it with a pat on the back, a pat. That was always fun. So if you see me doing that, please don't be surprised.
And now I understand Flocky's tweet, Chief Pat Officer. My husband was like, what does that mean?
Out of context, it sounds a little weird.
And I was like, I don't know, but I guess I'll find out.
Yeah, it comes from Pat. Yeah, nice. So we've done that.
Uh-huh.
We're approaching the top of the hour, which is fine. I say we keep going a little bit longer.
Yeah, looks fine.
Let's put this on. Let's put this on GitHub.
Okay.
And go from there. But first, let's take a look at our next step. Nice. Yeah, so we've served it locally. Oh, look at these exercises. Oh, fun. Okay, I love exercises. So we can modify the greet function in librs to take a name string parameter that customizes the alerted message and passes your name to the greet function from inside Wasm Game of Life www index.js. And rebuild the Wasm binary with Wasm build and refresh in your browser, and you should be able to see a customized greeting. Shall we give that a try?
Sure thing.
Awesome. So let's we're back in librs, which is great. Sejan writes, Pat is back. Yay. Somebody who knows it. Would you mind please closing the terminal you've opened there?
Sure.
In VS Code. Perfect. So in line 17, we've got our exported function greet, and now we can change it to take a parameter. And the way this works in Rust is in the parentheses on line 17, we can define the parameter. Are you familiar with parameters?
Yes.
Yeah, cool. So these are variables that we can pass to our function that can interact with it accordingly. So Flaky writes, achievement unlocked, perplexed Laura's hubby. Cool. So let's change our greet function signature. This is that's the definition of the function
Mhm.
to take that parameter. And it's going to be very similar to what we're doing in alert. So let's, inside those parentheses, type in name followed by a colon. And then that string slice, which is an ampersand. And then string. So that's the data type. So we're saying, hey, the parameter is called name and the data type is a string slice, which is good. Next,
is this an optional parameter?
Pardon me?
Is this an optional parameter, or did we just now define it so that this parameter is always required?
Great question. It is not optional.
Oh.
So now we've changed it to be non-optional.
Mm-hmm.
Now, next we're going to need to use that in our Rust. So let's, we're going to be using something called format we're going to be using a string, a Rust macro, that is a Rust function called format, to interpolate the value of name inside an existing string.
Mm-hmm.
That is, take the value and integrate it into the string. By the way, Laura, if you're short for time, I don't want to keep you.
Oh no, I'm all good.
All fine. Okay.
It's literally the vitamins reminder, and I was like, yeah, it's okay. I'll do it.
Okay. Sorry, I didn't want to put you on the spot.
No worries.
Yeah. So let's do that. Let's inside alert. So we're going to change it. So instead of using hello rustations, let's delete the contents of that string. Sorry, of those parentheses. Perfect. And we're going to be using the Rust macro format, which is an ampersand, format, followed by a exclamation mark. This is what usually from my understanding, this is usually a tell sign for Rust macros, which are special functions. I could be totally wrong on this.
Oh, okay.
So if you know better than I do, please do feel free to chime in.
Not even close, no.
Oh yeah, no, I feel like please always feel free to correct me. So, and that format command is going to take 2 parameters.
Okay.
So we'll need parentheses. Yep. The first one is a string. So quote marks. Sorry, quote marks for a string slice. What's that called? A string literal.
Okay.
And we're going to do hello, comma. And then here we're going to put in, what are they called? An indicator of where our next value will go inside that string.
Okay.
And for that, we're going to use curly brackets. Yeah, and a closing one. And followed by an exclamation mark. Oh, sorry. Yeah, exactly. Yeah. So we're saying hello, comma, and then please insert value here.
Mm-hmm.
Yeah. And so after that string, our second parameter is going to be the parameter of our greet function, which is name. And that's it.
All right.
So what we've done here, we've said, okay, we've redefined greet to take a parameter called name, and we're going to change that alert to, instead of displaying a string literal that just says hello rustations, we're going to say, hey, alert with this formatted string with hello, comma, and then whichever value I give to you, followed by an exclamation mark, and that value is whichever value we passed into name. Does that make sense?
Mm-hmm.
Great.
So now we're going to have to go back to where we used this function in index.js and give it arguments.
Absolutely.
All right.
So that's going to be a string.
Mm-hmm.
Oh, sorry. Quote marks. Okay. A string literal.
Aha.
And here, I'll let you please decide on one.
Oh goodness. Okay, so
not to put you on the spot.
What's that crab's name? Was it
Ferris with 2 R's?
Spelled like Ferris wheel?
Yes.
Okay.
as I learned recently from Flaky, who I think is still watching, it's not doesn't come from the chemical name, or I thought it came from the chemical name for iron, which is Fe.
Oh.
But it's apparently unknown. I could be wrong.
I see.
So yeah, now we're calling the greet function and giving it as a parameter Ferris, the string. Cool. So now we've got some steps we can follow to get that up and running. Let's go back to the terminal. Yep. So we want to cd out of the www folder, then do a Wasm pack build. That's done. Now we can go back to www and restart our npm server. That's done.
Success.
Nice. Do we want to try and just changing that from Ferris to something else, just to make sure that we've got that flexibility?
Sure.
Yeah. Cool. Let's go back to index.js and change it to be. I'm so bad at names. I'm so bad at coming up with example names on the spot. Let's go with world to be not super groundbreaking here. Perfect. So let's save that. And look at that. Webpack actually refreshed itself automatically when we changed our JavaScript file.
Oh, so it'll update automatically if we change the JavaScript file, but we have to recompile if we change the Rust file.
Correct.
Gotcha. That makes sense.
Awesome. Okay. I would say let's start putting this into a Git repository and call it a day. What do you think?
Sounds good to me.
And we're going to have to follow up because we didn't get to the game of life yet. But wait, we honestly, we got Rust, WebAssembly. We fixed Rust. So
right.
I'm super pleased. So let's go to
Do
GitHub.
we want to take a moment to change our branch name?
Oh, thank you for the reminder. Yeah. Now, the reason this comes as is because it's how it's defined in the template. But of course, the now best practice for a default branch name is main. So let's do that. So let's git checkout -b, and then the name of our new branch, which is main. So we're still copying over the Git history, so it should stay the same. And I believe we're good to go. We don't need to delete the other branch.
All right.
So we're going to add all of our files. And here we got some stuff going on. Let's have a look. You've added another Git repository module inside your current Git. Clones of the outer repository will not remain and will not know how to obtain it. I believe what's going on here is that we've initialized a npm project inside of our WebAssembly one, and with it created a Git repository in there. So what I would recommend, if I may, is to cd into www, and we're just going to remove that Git setting stuff from there.
Okay.
So let's remove, so rm, and pass in the flags rf, that is recursive and I believe force.
Okay.
.git. And let's do the same for git ignore. So rm, yeah. Ignore. Perfect. Let's cd back out and just add that all in. So let's do the same git add again. Nice. So great. We're going to go ahead and commit that.
Okay.
So that opens up our Vim editor. We're going to write our commit message. And of course, we are using conventional commits here. If you're not familiar with them, they're a way to document your Git commits so that they are, I believe they're good for, amongst other things, generating change logs. So that's a feature. And what did we do here?
Gosh, I mean, I guess we started a Conway package app. Would you call this a package or an app?
I don't know. I called it app in
the comments. Maybe Funky can tell us.
Yeah, no, please. I called it Wasm app in the YouTube description, but maybe I'm wrong.
We're gonna do that then.
Yeah, let's go. Let's be consistent. So that's done. So that's committed, but of course we now need to tell it to push somewhere, because we don't have, before we push, we still need to create a repository. Do you have one on GitHub that we are you logged in on GitHub? Can we create one?
I think I am. Yeah.
Sorry, we kind of didn't prepare for this part.
Well, this is how we're gonna get better at it, right?
Oh yeah, and I'm a big fan of showing the process.
I appear to be logged in. Yeah.
Wonderful. So at the top left in the burger menu, we should be able to create. You know what? Would you mind please expanding your window?
Yeah.
So that we can.
Oops.
Oh, that's perfect. That's perfect too. So now at the top right, we've got a plus icon. Yeah, we're going to create a new repository. Now we need a name. Shall we call it Wasm Game of Life?
Sure thing.
Excellent. And we're not going to add README. We're not going to add a git ignore. We're not going to choose a license, because I can see in our terminal there, they're already there.
Right.
So we should be good to go by just creating a public repository. Wonderful. Yeah. So that would be git remote. Oh, sorry. So we're gonna add it as a remote that Git can push to. So that would be git remote add, and then origin, and then paste in the URL.
That's going to be super handy, because I've been doing all this in multiple steps until today.
Oh, cool. And now we can git push origin main. And that's it. If you go and refresh your repository, there it is.
Yay.
Nice. So this means that when we pick this up again, and I think we're going to have to, because we got to keep going. We can, if we're on a fresh machine, we can just clone from here and keep going.
Excellent.
Awesome. Yeah. Well, that was, how you feeling?
Yeah, good. We did a thing.
We did the thing. Yeah. I'm super pleased. Let's go ahead and call it then.
Okay.
And yeah, that was super fun. Laura, thank you so much for joining me today.
Yeah, thank you for having me.
Yeah, and everybody on the chat, thank you so much for chiming in, for joining in, and it was a good time. I had a wonderful time doing some live streaming. I've missed this.
This is my very first one. So
no way.
Yes.
Nice.
Yes.
Well, if I may say, super smooth, super chill. I wouldn't have been able to tell.
All right.
Wonderful. Then again, thank you all for watching. See you hopefully soon, and take care, everyone.
Bye-bye.
Bye.